So guys, did you try solving problems from inequalities? Hello, can you hear me?
Yes, sir.
Did you face any difficulties? We can solve those problems. Tell me. You have any doubt in inequalities?
No, sir.
Sure. No doubt at all. Nothing. Very good. Can you see my screen?
Yes, sir.
Okay. Okay, inequalities. See, there are several types of inequalities we are going to see. See, yesterday we only saw first type of inequality, that is, the simplest form of inequality and how we can represent it on the graph, right? How do we represent it graphically, and how can we write it in form of sets? Okay, not set builder form. Now today we are going to see how word problems in inequalities. Okay, just give me a moment. Close doors. So we'll go via NCERT book. Let's solve let's try to understand question number 21. It says Ravi obtained 70 and 75 marks in first 2 unit test. Find the minimum marks he should get in the third test to have an average of at least 60 marks. Okay, so at least 60 it is saying. That means what? What is the meaning of at least? See, these are word problems, right? So you have to pay attention to the word. All right. So in first
Greater
test,
or equal.
sorry, it
Greater
means
or equal to, sir.
greater than or equal to. Yeah, of course. At least it is saying. So let's say in how do we find average of 3 tests? Let's say T1, he got 70 marks. T2 got 75, right? And in T3, how much this guy should get, Ravi should get to obtain at least, the average should be at least 60 marks. So how do we find average of these 3 numbers? So it will be T1 plus T2 plus T3, right? Upon 3. We just need to find the mean. That's what we call average, right? Should be greater than or equal to 60, right? That's what in the problem it is saying. Now we know the value of T1, T2, find the value of T3. See, whatever operation we do it in both sides of inequality. Okay, and see, the process is first we have to reduce the P by Q form into just the numerator form, right? we should try to eliminate that P by Q form. Okay, fraction form. Then we have to take care of the negative signs. If we have some negative sign, then we have to eliminate that, and in that case inequality will change. Okay, so take care of these things. See, so what we did, we just multiplied 3 in both side of the equation. Now what we'll do, we will okay, let's write it. So this is 70 into 70 plus 75 is 145, right? Plus T3 should be greater than and equal to 180. Now if we subtract 145 both side, so T3 will subtract 145. It is greater than or equal to 180 minus 145. Okay, how much we are getting? So we'll get T3. T3 should be greater than or equal to how much? 35, right? So in the third test, in third unit test, you should get more than greater than means greater than or equal to 35 marks, so that he can have an average of 60 marks. Okay, that means if he's getting 35 in the third test, what will happen? The average will be 60. All right. Okay, let's solve some other problem. This was the easiest of them all. Okay, so question number 23. Find all pairs of consecutive odd positive integers, both of which are smaller than 10, such that the sum is more than 11. Yeah, how we are going to solve this? See, find all the pairs of consecutive odd positive integers. Have you tried to solve these problems in your home? Yeah, can anybody tell me how we can solve this? Anyone? Or yeah, Murli? Yes, Murli.
Sir, one.
Shri Kruti and Shreya?
Sir, which exercise is this?
This is exercise 6.1.
1 minute.
Yeah, inequalities we are solving. No? So first exercise it is. Exercise 6.1, question number 23. Find all pairs of consecutive odd positive integers, both of which are smaller than 10, such that the sum is more than 11. Yeah, anyone? Anyone? Please tell me how you'll proceed for this problem. So let's assume something, right? First, we have to assume the smallest of two consecutive odd positive, smallest or the greater one. It's fine. Okay, so let's say x is the smallest, or b, x be the smaller of the two consecutive odd positive integers. Of the two okay, that means what is going to be the other integer? What will be the other integer, consecutive integer?
X plus 1.
X plus 2 it will be, right? Means, see, we are all the pairs of consecutive odd positive integers we have to find, right? Only odd. That means if x is 5, that means the next consecutive odd positive integer will be 7, right? I'm sorry, yeah, according to what I asked, you are correct. I said just integer, not odd. So you are correct in that respect. Okay, so other number will be x plus 2, right? Every second number is odd and every second number is even also, right? Okay, now what else is given in the question? Both the integers are smaller than 10, right? That means if both the integers are smaller than 10, that means x plus 2 is obviously less than 10, right? So x must be less than 8. Yeah. Right. Now what else is given? That sum of both the integers, right? So x is first integer plus x plus 2 is second integer, odd integer. Of course, we are talking about odd positive integer. Okay, and this is greater than 11. That's the sum is greater than 11. So what we are getting from here, 2x plus 2 is greater than 11, right? If we subtract negative to both sides, or if we add negative to both sides, what we are going to get? 2x plus 2 plus minus 2 should be greater than 11 minus 2. Okay, so this will be 2 times of x should be greater than 9. X must be greater than 9 by 2. So x must be greater than 9 by 2 and x must be less than 8, right? So these are the two conditions that now we are having. Okay, so what are the all possible values of x? Integer values, odd integers. See, let's draw the number line. Let's try to represent it on the number line. Okay. So what are the critical points we are getting? 1 is 8. Okay. X should be less than 8. That means we'll use a solid circle to represent it. No, not solid, hollow circle, right? So hollow circle to represent, because we are not including 8. It is less than 8. Okay. It should be less than 8. And it should be greater than 9 by 2. 9 by 2 is 4.5. So let's say another critical point is 4.5. It must be greater than 4.5. And it has to be an integer, right? And odd. So what are the integers greater than 4.5? So it can be 5, 6, 7. These are the 3 possible integers which is greater than 4.5 and lesser than 8. Okay. Now we have to find only odd positive integers, right? So what are the odd positive integers? 5 and 7, right? So your answer is x is equal to 5 and another number, that is x plus 2, is equal to 7. So 5 and 7 is your answer. Understood? You got it? Anyone is having doubt here? We can go through it again. See, in the problem it is given that find all the pairs of, that means we are having only one pair, right? We are having only one pair. X is equal to 5. Sorry, we cannot write like that. So the pair, in pair we can write 5, 7. That's it. This is the pair that we are looking for. First number, if first number is 5 and 7, we don't have any other number, right? Okay, just wait. I think I have made. Okay, x here, it is greater than 9.2, right? Okay, and it should be less than 8. So we are correct, right? This is the correct solution, right? Isn't it? It can take only value 5 and 7. That's it. X is greater than 9 point. Yeah, this is correct. Yes. Okay, let's solve another problem. Find all. Okay, now see, in sets we have seen union and intersection. Here in words we represent union by or and intersection by and. Okay, so whenever we have a statement like and, we are going to take intersection, and whenever we are going to have or, we will take the union. Okay, so let's solve a problem based on that. So x plus 2 is greater than or equal to 0, or x minus 3 should be lesser than 1. Okay, so now we are into compound inequalities. Like we have two different statements, right? First statement and second statement. So how we are going to solve these type of inequalities? And we have or in the middle, right? Either it will take this value or this value. It can take any of the values. So from here, if you solve the first equation, what we are going to get, x should be greater than or equal to -2, and the second one, x should be lesser than what, 2. Okay, now these are the two critical points. All right, so let's make the number line. Okay, let's make the number line. Okay, now the first critical point is 2 and the second critical point is -2. Okay, now from the first statement, what we are getting is x should be greater than or equal to -2. That means we'll use a solid circle to represent it. Okay, that means we are including the value of -2, and it is greater than, that means all the possible values which is greater than -2. Okay, and for the second one, from the second statement, what we are getting, x should be less than 2. So now we are taking these values, okay, with open circle. Now you see it is defined for all values of x, because we have to take union, right? So if you take union, so how we can write solution of first one, x belongs to minus 2, sorry, closed interval we'll be using, because it is we have equality sign here, see, that's why closed interval, -2 to infinity. And from the second one, what we are getting, union 2 to infinity, sorry, my -infinity to 2. Okay, so if you take the union, that means we are getting all real numbers. X belongs to real numbers, right? Okay, either the value of x can be this, the green one, or the red one. Okay, understood? So this, because this equation is satisfied. All right, let's see a problem based on AND statement. Okay, so same problem. Let's say x plus 2 is greater than or equal to 0, and x minus 3 should be less than 1. Now again, the solution is same. So x must be greater than or equal to -2, and x must be lesser than 2. Again, we are going to make that number line. Let's try to understand using that. We have two critical points, -2 and 2. Now again, let's plot it. So from the first statement, we are getting x is greater than or equal to -2. So again, we'll use solid circle to represent it, and all the values greater than this. Okay, and x must be lesser than 2. Now here we'll be using open circle, right, to represent it. That means from the second statement, we are getting only the green lines, right? So from first statement, the solution of first statement, it is x belongs to -2 to infinity. And from second statement, we are having x belongs to 2 to infinity, sorry, what is that? -2 to 2. Okay, with open brackets, because we are not including the value of 2, because there is no equality sign here. Okay, so we have to take intersection, because we have an AND statement. It both the equation must satisfy the value of x. So x belongs to -2 to infinity, intersection -infinity to 2. So if you take the intersection, we'll get x belongs to what? -2, -2 to 2. Okay, so this is going to be your answer for AND statement. Understood? Anybody's having doubt here? Understanding the open circle, the brackets, because we have studied this in sets as well as in functions. In functions, we have found the domain and range. That's how we are going to find the domain and range. All right, inequality sign. We are always using inequality sign. Okay, so okay, so solve this problem. X. Okay, let's write down. Find the domain of the function y is equal to 1 upon square root of 1 minus x. Yes. Find out the domain. Okay, let's leave this problem. Just first write down square root of 1 minus x. Yeah. Let me add a real valued function. Okay, real valued function. Only real solution we need to find out. Yes. Anyone?
Sir, x is lesser or equal to 1?
X is
Lesser or equal to 1?
Okay. See, we need to define this function, right? The function given
Yes,
is
sir.
y equal to square root of 1 minus x, right? Now, if under the square root, if this value is greater than 1, then only the greater than or equal to 0, then only it is defined, right? If it is less than 0, that means the
Sir,
negative.
sorry.
It will
Sorry.
not be defined. So 1 minus x must be greater than or equal to 0. Then only this is for the function to be defined. Otherwise, the function will be imaginary. No values will be getting. So for what we are getting from here, we'll add x both sides. So 1 must be greater than or equal to x, right? Isn't
Yes,
it?
sir.
Okay, so 1 must be greater than or equal to x. 1 cannot be less than x. Okay, so again, the number line, let's go to the number line. Now x is equal to 1 is the critical point, and because there is a equality sign, we'll be using dark circle or solid circle to represent it. Okay, and it has to be x has to be lesser than 1. X cannot be greater than 1. Okay, so x belongs to negative infinity to 1. In 1 we are taking the value, so we'll be using square bracket that represent closed interval. Okay, so that's the solution. Okay, so this is the domain of the function. Okay, now similarly try to find the domain of this function. Y is equal to 1 upon square root of 1 minus x. Find the domain of this function.
Sir, x is an element of minus infinity to 1 with open brackets.
With open bracket, very, very good, because this function, see, it is in p by q form, so q must not be equal to 0. See, this is the first condition.
Yes.
Also, see, because this function, it is square root of q, right? So q must be greater than or equal to 0, right? But now q cannot be equal to 0, so q must be greater than 0 for the function to be defined. Now what is q? Q here is 1 minus x must be greater than 0. So x must be less than 1. Okay, so again in the number line, how we'll represent it? So x critical point is 1. We'll use open circle. Okay, so these are the all possible values where the function is defined. So you'll write the domain is x belongs to negative infinity to 1 with open bracket. Okay, see, in infinity we will always put open bracket because it is not defined.
Yes,
All right,
sir.
hopefully this thing is clear to you now. Okay, okay, let's solve question number 25 of your book. Exercise same. What is that? Which exercise is this? 6.1. Yeah, 6.1. Solve that problem. 25. See, the question is the longest side of a triangle is 3 times the shortest side, and the third side is 2 centimeters shorter than the longest side. If the perimeter of the triangle is at least 61 centimeter, find the minimum length of the shortest side. Okay, okay, just try it yourself. Try it yourself. Okay, so some triangle is like this. Let's say A, B, C. Let's say this is side 1. So let's say A1. Let's say this is side 2, A2, and side 3, A3. Okay, so these are the 3 sides of a triangle. Now the longest side of the triangle is 3 times the shortest side. So now in the according to the problem, A1 is equal to 3 times of A2, right? A1 is 3 times of A2. Okay, understood? What else? And the third side, and the shortest side is, and the third side is 2 centimeters shorter than the longest side. Now the longest side is A1. So A3 is equal to A1 minus 2. That means now A1 we know is 3A2 minus 2. All the measurements are in centimeter, okay? All measurements are in centimeter. So this is what is given. Now, the perimeter. So perimeter is what? The sum of 3 sides. Perimeter is A1 plus A2 plus A3, right? So it's given that perimeter is at least 61. So it is greater than or equal to 61 centimeter, right? Now perimeter is A1. So A1 is 3A2 plus A2 plus A3. A3 is 3A2 minus 2, right? This should be greater than or equal to 61. Now find the value of A2. Yeah. So we'll add 2 both sides and we'll add these 3. So 7A2 should be greater than or equal to. Now if we'll add 2 both sides, so this side will remove this part and we'll have 63. And if we divide both sides by 7, what we can write? A2 should be greater than or equal to 9 centimeter, of course, right? Understood? So, and now A2 is the shortest side, right? That means the shortest side must be greater than or equal to 9 centimeter. Understood? So it's really easy problems. These are really easy problems, right? You just need to go with the words, English language. And I'm very much sure you are really good at it, at least better than me. So yeah, so let's solve inequality of, okay, so in 2D graphs, let's draw inequalities in 2D plane. Inequalities. See, if anybody is having doubt, you can ask me right now. It's fine. Okay. Anybody is having doubt, please tell me. We can go through any problem if you want. No doubt? Okay. So inequalities in 2D plane. So inequalities in 2D plane. Okay, so let's say, let's understand this using a problem itself. Okay, so from exercise 6.2, this is the first problem, that is x plus y should be lesser than 5. Whatever value of x and y you take, it should be lesser than 5. See, in these case, first we see, you can see this is equation of a straight line. Equation of a straight line. Straight line. So what we'll do, we'll assume, let's assume x plus y is equal to 5. Okay, now we will plot this straight line. Okay, let's try to plot this straight line. Let's say this is y, this is x. Okay, now we have x and y, and we have an equation in x and y, right? All right, so this is y, this is x. All right, now how do we plot the straight line? Even if you don't know, so we can make a, a box. Let's say a box of x and y, right? So x is your independent variable, y is your dependent variable. Okay, let's say that if x is equal to 0, see, we need only 2 points to plot a straight line. So if x is equal to 0, y is equal to 5, and if y is equal to 0, x is equal to 5. It's really simple, right? So let's say 5, this point is in x-axis, so 5, 0, and this right here, it is what? 0, 5. That's what these are the 2 points we are getting. So whatever straight line will get, it will pass from here, right? So let's plot this straight line. Yeah, so this is the straight line that we are getting. Let's increase its length. Now see, what equation we need to solve? We need to solve x plus y should be lesser than 5, right? That means now there is no equality sign here. See, there is no equality sign. So what we'll do, we'll draw a dotted line, okay, rather than a solid line. What we'll do, we'll draw a dotted line. So stroke precision, okay. So I'll just try to dot these lines, make dots here. Okay, so the dotted line represent that we'll take all the values but this value. Okay, now it is saying that x plus y is less than 5. So this is the line. This is the line. X plus y is equal to 5, but we are not taking 5. So whatever values we are taking, all are lesser than this value. So x plus y, all the value lesser than this. So all the values here. So this is the graphical representation. All the values which belongs here. Okay, lesser than we are representing. Below this line. Okay, so the point can be here. The point can be here, here, anywhere, but not here. It cannot be here. Okay, because this will be x plus y greater than 5. Okay, it will not be lesser than 5. Understood? It's a really easy problem, right? We can solve these type of problems, isn't it? Graphical method. So that's what is your exercise 6.2 all about. So which problem do you want me to solve from? Okay, let's see. See, I think we have to solve only for straight line. We don't have any other functions to plot. Okay, now let's try to plot straight lines with 2 variables. Okay, functions, solution of system of linear equations in 2 variables. See, this is single variable, right? We have only one equation. We have only one equation here. But if what if we have 2 variables? So let's write down. Okay, solution of system. See, excess. Now, if you have understood this part, that means you can solve any problem of exercise 6.2, any problem. Okay, any problem at all. Understood? So if the equality sign is not there, you will draw a dotted line. If there is equality sign, you will draw a solid line. Okay. Okay, so solution of system of linear inequalities in 2 variables. Okay, so now we have to solve in 2 variables. That means we'll be given two equations. So let's say x plus y is greater than or equal to 5, and another one is x minus y is lesser than or equal to 3. See, 2 equations, 2 variable, we all know how to solve it. We have studied that in 10th standard, right? So you have studied how to solve linear, not linear equalities, you know how to solve it, but these are linear inequalities, right? That means there will be a portion, there will be finding a reason. Okay, so let's try to plot both the curves. So first one, we'll use the same method. We'll draw the box, the dependent and independent variable x and y, and we'll plot it. Okay, so x plus y, if x is equal to 0, the value of y will be 5 for the first equation. If y is equal to 0, the value of x is going to be 5 for the first equation. Okay, now let's draw the second one. Same. So x, y. Now if x is equal to 0, the value of y is -3. If y is equal to 0, the value of x is +3. Okay, now let's try to plot these 2 straight lines. So let's say this is 1 and this one is 2. Okay, now let's draw the graph. Okay, so this is y, we have this x. Okay, y, x. All right, now if x, first let's plot the first one. Okay, so first one will plot with red color and the second one will plot with green color. Okay, so the first one. Okay, so if x is equal to 0, that means y axis, and so y is going to be 5. If y is 0, x is going to be 5. Okay, so kind of similar to the previous one. Now we'll draw a straight line. Okay, So let's draw, let's extend it. Okay. Now see, we will draw a solid line. Why? Because there is equality sign. If you see, we have equality sign. In this case, there was no equality sign. So we draw a dotted line to represent it. The second one, okay, let's say the second one, let's say the second one is not equal. Okay, let's say that. Now let's draw it with a green curve. So if x is equal to 0, y is equal to -3. So if x is equal to 0, y is equal to -3. If if y is equal to 0, x is equal to 3. So if y is equal to 0, x is equal to 3. So somewhat around here. Okay. Now let's draw the line. Okay. So we're connecting these 2 points. I'll extend this line. Okay. So somewhat like this. Now the equality sign is not there. So what we'll do? We'll draw a dotted line. We'll draw dotted lines. Okay. So we'll draw dotted lines that represent it is not equal to. Okay. Dotted line represent it is not equal to. All right. Now see the first one. It says x plus y is greater than or equal to 5. That means all the values this side above the axis or above the red line. Okay, here all the values here. Okay, all the values here. The second one says that x minus y should be lesser than 3. So which reason we are going to take? X lesser than 3. Which reason is lesser than 3? So it is to the left side, right? Understood? So it is to the left side. Where is that? This side. See, if you get confused, just put any value. Let's say, see, origin 0, 0. This point is 0, 0. In first equation, if you substitute x is equal to 0, y is equal to 0, you are getting 0, which is not greater than 5. That means this graph is correct. Now in the second equation, if you plot x minus y, so if you put 0 in both, you'll get 0, which is lesser than 3. So it satisfies. All right. You take any point here. Let's say this point is 5, 0. So if you put 5, 0 in first equation, you'll get 5. That means it is not less than 3. Okay. So this graph is correct. Now, which is the common area in both? Okay. Which one is the common area? So let me extend this one. Okay. So which one is the common area? Okay. This one, right? So these values, these are the common areas, right? So this represent your this side. Okay, these all represent your this system of equation. The system of equation that we need to solve. This one, it can be represented by here, this area. Okay, understood? This area A will represent your this system of equation, possible solutions. Okay, understood? Because we'll be taking the intersection of these two curves. Is this part clear or not? Yeah, is it clear? Or do we need? Okay, we'll solve some of the problems. Let's solve question number. Okay, so we are given two system of equation inequalities. So that is 5x plus 4y should be lesser than or equal to 40. And there are other conditions given that x must be greater than or equal to 2 and y must be greater than or equal to 3. Okay. Now we just need to plot the straight lines here, right? So we have got 3 critical points. Okay, so what will be the possible solution? So this is, we know, a straight line. So what we'll do? Again, we will plot the straight line x, y. Now if you substitute x is equal to 0 in this equation, what you are going to get? Y is equal to 10. So if x is equal to 0, y is equal to 10. And if y is equal to 0, y is equal to 0. So what you'll get? X is equal to 8, right? So we have got 2 points for the straight line. That means we can plot the graph. Let's come to the graph. So this is y, and say this is x. Okay, so this is y and x. We have 2 points. So if x is equal to 0, and y is equal to 10. So let's say some point here. So this point represents 0, 10. Now if y is equal to 0, it is 8. X is equal to 8. So 8, 0. Okay. Let's use red curve for this. No, green we are using. Sorry. So 8, 0. So this is the point. Now let's draw. See, because there is equality sign. So what we'll do, we'll draw a solid line here. Let's extend the line. Okay. So this is the line, the name of this line is 5x. Sorry. 5x plus 4y is equal to 40. Now x should be greater than 2. Let's plot x is equal to 2. So if x is greater than 2, what do we mean by that? So somewhere x is equal to 2 here. So 2, 0. So let's plot x is equal to 2. So again, it is going to be a straight line parallel to y-axis, right? So let's say this is x is equal to 2. Okay, so for the first curve, it should be lesser than 40, right? So it should be lesser. That means this side of the curve, the bottom side, or this side, lesser than, right? Now for x greater than or equal to 2, it should be this side, greater than. We need x greater than 2. Now the third one, let's use some different color. The third one, let's use yellow. Okay, so the third one is y should be greater than or equal to 3. So y, let's say y is equal to 3 here. So 0, 3. Okay, so let's draw a straight line here. Now, according to the problem, let's extend it. Now, according to the problem, what we are having, y should be lesser than 3. So all the values less than this line, below this line. Okay, so below this line. What is the common part we are getting? What is the common reason we are getting? So this triangle is the common reason we are getting, right? Isn't it? So this triangle, okay. Let's use some other color. Let's use blood gray or some other color, which, okay, so I'm out of colors. Okay, so this one. So this reason will define the inequality. Understood? So this inequality, uh-oh, why we are not getting it? Okay, anyway, so this inequality can be defined using this reason. Understood? So that's how you are going to solve it in exam also, or for any problem graphically. Is there any doubt in graphical representation of linear equations? You can solve any problem. See, same thing again we are going to repeat in statistics. Okay, that is again there, that will be there. So if you follow this, you can solve all the problems from exercise 6.3. Okay, all the problems. See, there will be just compound inequalities. Okay, so if there is a comma in the middle, you'll be taking the intersection. You will not be taking the union unless a statement is given and or. If or statement is there, you'll be taking the union. If and statement is there, you'll be taking the intersection. Okay, so just try to solve this problem by yourself. Exercise 6.3, question number 12. Question number 12, it says x minus 2y should be lesser than or equal to 3. The second equation is given, 3x plus 4y should be greater than or equal to 12, and the condition is also given, x should be greater than equal to 3 and x comma y both should be greater than equal to 0. Of course, if x is greater than or equal to 3, that means it is greater than equal to 0. That condition is already written here. So try to solve this problem. And I'm really sorry about the background noise. I have no control on it. If you are able, if you can listen in. I'll just try to solve this problem. I'll mute it. I'll give you 2 minutes for that. So hopefully you are able to solve it. Anybody is having doubt here, so please let me know. See, again, we'll be repeating the same thing. So we'll be plotting the equations. Okay. So I'll just directly plot the curve. So we use the same method. Okay. Same method in X and Y. X, Y, if X is equal to 0, Y is going to be what? What is going to be Y? And if Y is going to be 0, X is equal to what? So Y is equal to 0, X will be 3. And if
Yes,
X is
sir.
equal, yeah, and if X is equal to 0, what is the value of Y? If X is equal to 0, the value of Y is, yes, anyone? 3 by 2, right?
Yes, yes.
Yeah, 3 by 2 it is. That means 1.5. Similarly, for the second equation, xy. So it is, if X is equal to 0, the value of Y is 3. If Y is equal to 0, the value of, sorry, if X is, yeah, so Y is 3. If Y is equal to 0, X is 4. Okay, let's plot this. Okay. Okay, see, it's already given that X and Y both are equal to 0, so we don't need to go into more into negative side. So we can just draw the positive direction, positive side. Y, X. Now, this equation, the first one, if X is equal to 0, if X is equal to 0, Y is 3 by 2. Y is 3 by 2. So 0, 3 by 2, that is 1.5. And if Y is equal to 0, X is equal to 3. So somewhat around here. So we just need to draw a rough sketch. We don't need to, scale it. No need to scale it. So this is the first curve. Let's use the green color to represent it. Okay.
Sir,
So yeah,
so that should be minus 3 by 2, right?
minus
3 by 2.
Yeah. Sorry. Yes. Correct. It is negative. Correct. Thanks. This should be negative. So this plot is incorrect. Yeah. Thank you. So this should be minus 3 by 2. So let's plot it. Hopefully you guys are able to solve it, right? I don't think there will be a problem. But if you have, feel free to ask me. It's fine. Y and X. So if X is equal to 0, Y is negative 3 by 2. That means in the negative direction. Okay. So we have to draw it kind of. Okay. So let's say X. So if X is Y is equal, sorry, X is equal to 0, Y is equal to here, somewhat around here. So 0 minus 3 by 2. And if Y is equal to 0, X is equal to 3. So somewhat around here. Let's say 3, 0. So let's represent it by this curve. Extend it. I'll just extend this curve. Okay, so the value is lesser than this, right? The value is lesser than this, isn't it? So how you will represent the lesser than this value? Which side? If you are having confusion, if you are having confusion, what you do? See, origin is on the top side, right? 0. Origin is 0, 0. So you just substitute in this equation. Okay, if you put x is equal to 0 and y is equal to 0 here in this equation, what you are going to do? You'll get 0. Now 0 is lesser than or equal to 3. That means you have to use this side. All the equations, all the curve this side. Okay, so this side, on the top side. Okay, this side, this side, this side. Okay, very good. Now let's plot the second one. If x is equal to 0, y is equal to 3. Very good. So if x is equal to 0, y is equal to 3, somewhat around here. So 0, 3. And if x is equal, y is equal to 0, x is equal to 4. So somewhat around here. Let's say here. So 4, 0. Okay, so let's plot the straight line. I'll extend it a little bit. Now again, check with the origin. Okay, origin is this side. Origin is here, right? Now if you substitute this value here, what you are going to get? 0. Now 0 is greater than or equal to 12. No, it is incorrect. That means all the values above it. Right? All the values above it. Anybody is having doubt here, we can go through it. So you just need to check any point. And what better point than origin? See, if you substitute the value of origin, that means x and y both 0. You will get to know whether it is correct or not. Because if you substitute x and y both 0 here, so what you'll get? 3 into 0 plus 4 into 0, that is 0. And it is not greater than equal to 12. It is lesser than, right? So that means this part, this side value is not possible. This is incorrect value. All the values above it. Okay, this side of the curve. Now it is also given that x and y must be great. X is greater than equal to 3. One more point. So x should be greater than or equal to 3. So let's use red curve to represent it. So x is greater than equal to 3 can be represented by this line, right? So greater than, so this side. Of course, if you have greater than, that means this side, right? This side. And y should be greater than 0. That means y is greater than 0. That means all the values above x-axis. So let's use yellow color. All the values here above this axis. So what is the common reason we are getting? We are getting this common reason, right? Only this is the common reason we are getting. Let me draw it. That. So this is the reason that we are getting. Okay. This is the solution of this given linear equation. Understood? So you can see how, in exam how you are going to write. So you'll just name this curve A, B, C, or suppose some curve, whatever curve you are getting. You just name all the points, all the corner points, and write down the region bounded by these points will be the solution of this possible solution of this linear inequality. Okay, so similarly you can solve all the problems of exercise 6.3. okay, let's come to exercise, the miscellaneous exercise. If you have you have to solve it. The thing is, whatever problem you have to solve it. Okay, there is no skipping out of it. You solve it, you ask me doubt. I cannot solve all the problems in here. Okay, we have a lot of problems and all problems are similar. All problems are very much similar. Okay, so miscellaneous exercise. So the concepts will remain same. All the concepts are same. Okay, so let's solve question number 6. I'll be solving one problem, and we have word problem. Again, the word problems are exactly similar. The solved examples, go through solved examples. Solved examples. Ask me doubt. In next class, you can ask me doubt. See, next class we are going to have next Monday. So you can ask me doubt then. So 7 should be lesser than or equal to, and if we don't, then we'll be starting statistics. Okay, we'll be studying statistics that day. should be lesser than 11. Okay, how you are going to solve it? So you can write it separately. So first equation you'll write, see, this is again compound inequality, 3x plus 11 upon 2. And next, the second one, what you'll write? You just write 3x plus 11 upon 2 should be lesser than equal to 11. That's it. Now let's solve the first one. So first one, you just multiply with 2 both sides, will get 14 lesser than equal to 3x plus 11. Now if we subtract 11 both sides, we'll get 3 should be lesser than equal to 3x. Now divide both sides by 3. What we'll get? 1 should be lesser than equal to x, or we can write x must be greater than or equal to 1. So we got one solution from here. Okay, so from here, what again multiply by 2 both sides, we'll get 3x plus 11 should be lesser than equal to 22. And if we subtract 11 both sides, we'll get 3x should be lesser than or equal to 11. And if we divide both sides by 3, we'll get x should be lesser than equal to 11 by 3. Okay, so we have got 2 solutions. Now let's draw the number line. See, always try to plot, solve using graphical method. It is always, it will very less chance of error will be there. So 2 critical points that we have. The first one is 1. First one is 1. And the second one is 11 by 3. Now, according to the first equation, this first solution, we get x should be greater than or equal to 1. Okay, that means we'll use solid circle to represent it. And the values must be greater than. So all the values this side. Okay. And the second one, from the second one, what we are getting, x should be lesser than or equal to 11 by 3. That means again equality sign is there. So we'll use again dark circle, dark solid circle, and to lesser than. So all the values this side. Okay. Now what is the common part that we are getting? So this is the common part we are getting, right? So the possible solutions of x belongs to 1 to 11 by 3 and both closed interval, because we are taking the value of 1 and 11 by 3. Understood? Similarly, you can solve all the problems. It's really, really easy. Okay. And same thing goes with graphical, like question number 7 to 10. You can solve it graphically. Same method, no changes. Okay, just follow the rules. Okay, just follow the rules. Rules are, first you try to convert p by q form in just the integer form, or what we can say, just write in terms of numerator. Try not to change the sign. Okay, try not to change the sign. Like here, you just don't write like 3x is, just don't try to take it to the left hand side or the right hand side unless you solve for x. First, remove the denominator, then remove whatever adding or subtracting is there in the variable. We always want to find this x, so act according to that. See, first what we did, first we multiplied it with 2. If we multiply it with 2, we can just remove this 2, right? This 2, and we'll multiply it here. We'll do the same operation on both sides of the inequality. And then what we did, we subtracted 11 both sides. So minus 11 plus minus 11. So what we get 3 here, and 11 minus 11, we reduce this. Now 3x, what we'll do, we'll divide it by 3, both sides. So it will boil down to 1 lesser than or equal to x. We want only this variable x, so act accordingly. Okay, accordingly, if you act, you will Okay, I'll end the class here. We'll have it on Monday, next Monday. Thank you so much. Bye.
Thank you, sir.
Thank you, sir.